This is the story of one man, a box of tiny parts, and a lot of patience. Over the course of several weeks, he built something incredible, a remote-controlled Audi car, not just for its appearance, but packed with real mechanical systems, engine, transmission, suspension, even power steering. And the wild part? It all works. The project began with the engine, a working miniature engine, just like in a real car. The builder started with the starter motor, which is what helps an engine begin running. Once that was in place, he attached the flywheel, a spinning disc that keeps the engine smooth while it runs. Then he connected the starter to the flywheel, making the crankshaft rotate. The crankshaft is the part that turns the up and down movement into rotation, essential for making the wheels spin later. To control how power moves from the engine to the wheels, he added a pressure plate and a custom clutch disc. The pressure plate helps the engine connect or disconnect from the transmission. The clutch disc transfers the power, or torque, without slipping. With the pressure plate and disc in place, the clutch assembly was locked down. A release bearing was also added. This tiny part makes sure the clutch works properly when the driver wants to switch gears. Once the engine was ready, the focus moved to the transmission. This part controls how fast the wheels spin, depending on how fast the engine is going. Each gear was ground smooth to fit perfectly. Rough gears create noise, waste power, and wear down faster. These ones were polished and carefully shaped so they'd fit together like puzzle pieces. Then, the gears were installed one by one onto the main shaft. They had to be placed exactly right, with support bearings holding them steady. Bearings are small rings that reduce friction, so the parts can spin freely. After checking that the gears move smoothly, the builder added the countershaft. It runs beside the main shaft and lets the gears work together to change speed. The two shafts were then installed into the transmission housing. This is the metal case that holds all the inner parts in place. To make sure the transmission didn't leak, a gasket was added to seal the housing tightly. Then, gear oil was added using a syringe, just like a real car mechanic would do, but on a smaller scale. After sealing everything, the housing was bolted shut. It was now a complete transmission, ready to work. Next, the gear selector was connected. This part lets the driver, or remote controller, choose different gears. It was linked to an electronic servo motor, which moves the gears remotely with high precision. Now, the engine and transmission were coupled together. This made one complete powertrain system, ready to move the RC Audi. To split power between the left and right wheels, a working differential was built. This is important because cars need the left and right wheels to spin at different speeds when turning. If both wheels spin the same all the time, the car could lose control in corners. The differential solves that by adjusting the power split during turns, or on uneven ground. The rear suspension subframe came next. This is the structure that holds the rear suspension in place and absorbs bumps from the road. In RC cars, just like full-size ones, it helps keep the ride smooth. Then, he attached the wheel hub and knuckle. These parts hold the wheels and allow them to turn and spin freely. Control arms were installed to connect the suspension to the main body of the car. Together, these parts allow the car to move over bumpy surfaces while staying balanced. Every part was tested to make sure it worked exactly as it should. With the suspension in place, it was time for tires. These weren't just toy wheels. They were high-performance rubber tires made for grip and speed. Each one was tested to make sure it could handle fast driving and sharp turns. To stop all that speed, the car needed brakes, so brake supports were added to hold the brake system steady during high-pressure stops. Just like in a real car, the supports stopped the brakes from shifting or braking during use. The final step for the wheels was mounting everything to the rear axle. With the hubs, control arms, and suspension all connected, the back of the car was nearly complete. The front suspension came next. Just like the rear, it needed a strong subframe to keep everything in place. The subframe was aligned with extreme care to ensure balance and correct geometry. Even a small mistake in alignment could throw off the steering. Once the frame was set, the wheel hub and steering knuckle were added. These parts let the front wheels rotate and respond to steering commands. Control arms were installed to link the front suspension to the main chassis. These arms move up and down with the wheels, keeping the car stable while driving over uneven surfaces. Then came the steering rack. This component controls how the front wheels turn. It was tightly fixed to the chassis to prevent any wobble. Tie rods were connected to each end of the rack, linking directly to the wheels. This setup allowed the car to steer smoothly, just like a real vehicle. To make the steering easier to handle, the builder added an electric power steering system. This helps the car turn more easily, especially at high speeds or in tight corners. Before painting, all parts of the RC Audi were thoroughly cleaned. Dust, oil, and grease were wiped away so the paint would stick properly. A layer of primer was applied first to create a smooth surface. Then the car body was spray painted with even strokes, giving it a clean and polished look. The final result was impressive. The body design was based on the Audi 100 Coupe S, a stylish performance car first released in 1969. The builder matched the shape, size, and details of the real vehicle, making this RC version a near-perfect copy. With the engine, transmission, suspension, steering, and body complete, it was time to bring everything together. The engine was mounted on the chassis, the transmission and differential were connected, the suspension was bolted down, steering components were locked into place, tires were installed, wires were checked, fluids were topped off. Now, the builder placed the RC Audi on a dyno test stand. This is a machine that measures engine power, speed, and torque. It lets the builder test how well the car performs without driving it on the ground. Gears were shifted through the remote system. The dyno showed how the car responded at different speeds and under different loads. Everything worked. The gears changed smoothly, the engine ran cleanly, the brakes reacted fast, the steering turned with precision. After hours of hard work and detail, the Mini Audi was alive. Spending $7,000 to build a tiny car might seem like a lot, but for this builder, it was worth every penny. He didn't just build a remote control car, he built a working tribute to one of Audi's most iconic vehicles, complete with a running engine, real suspension, working brakes, and gear shifts.